So if I give you this function and I say g of x is equal to 6 times 3 over 2 raised to the x. A couple of things I want to point out to you guys, and we could just graph this, and we will in a second. Well, actually, let's just do that. So take out your calculators, turn those bad boys on. Oh, my computer's going really slow. I might have to. I clicked on it. What's going on? There it is. I clicked on it twice, which made it take longer. So if I graph this, how do I graph it? Well, I go into y equals, right? Clear out what's in there. I'm going to hit 6, open the parentheses. I'm going to say 3 divided by 2 raised to, and then I'm going to plug the x in here. Okay. Now, I hit enter. I'm going to go to, I'm going to change the window. So follow along with me. Hit window. And I'll wait till you get to this screen. Let's go from -4 in the x direction to +4. And then for my y minimum, I'm just going to put that at 0. And then for my y maximum, I'm going to put that at 14. Oops. I forgot to hit enter, didn't I? So my y maximum is 14. So you see what I got on my screen there? X minimum is -4. X max is +4. And y min is 0 and y max is 14. Now what that does is that's going to set my window from 0 to 14 in the vertical direction, the y direction, right? And then from -4 to 4 in the x direction. Okay, so let's look at this bad boy. Hit graph. And it'll look something like this. Okay. Now, what I want to do is look at the table of values. So if I look at the table of values, I hit second graph. See this little word up here above the graph where it says table? And I'm going to scroll down to, whoops, I want to go up to 0. Or actually, I'm going to do -1. Now, if you're really far away from -1, I'm sorry. So I'm just going to do -1 to 2. All right. So for my x values, I'm gonna check -1 to 2. So now that I've got those values, and we're going to graph those and take a look at those in a second. One thing that I want to point out, this is always referred to as the base. And this would be kind of what you would call the growth / decay rate. So that's what it grows by, or that's what it decays by. Now this is growth because it's greater than 1. So there's a couple of things. If it's greater than 1, it grows. If it's a fraction and it's less than 1, it decays. And sometimes we can have a negative value in there. But that's something different. So just remember that. This is the base, and it's usually some sort of rate because that's what we're raising to a power. Okay. Now, what do you think 6 is? Well, 6 is always this term right in front of that is what we usually refer to as the initial condition. So if I start off with a petri dish that has 400 bacteria in it, or bacteria, the plural is the same as the singular. If my value that I would plug in there will be 400, and if they double every day, I would put 2 in parentheses, and I'd raise that to the x, and x would represent the number of days. All right. Well, we're just going to be asked to graph and notice these key features. So the first thing I want to point out is that the initial condition occurs at g of 0. In other words, it occurs when x equals 0. So notice that when x equals 0, y equals 6. That's no accident. Okay. Now, when we look at this graphically, I'm going to take a snapshot of the graph. So do me a favor. Pull your screen back up on your computer, go and hit graph, and let's take a look at the graph. See this button here that says trace? Trace lets me see spots on the graph. So when I hit the trace button, if I go to -1, see how it says x equals -1? It'll tell me the corresponding y value. All right, does that match up? Yep. Notice that when I hit 0, when I'm in trace mode, if I hit 0, it's right here at 6. Now, if I'm measuring something that's growing, I would never start with -1 bacteria. So sometimes in the real world, the domain changes as opposed to the theoretical mathematical model. We're using this curve to predict how many bacteria we'll have or how much money we'll have. But we might not use that whole curve. We might just use a portion of it. Okay, and we'll talk more about that. So if I want to graph this anyways, let me go ahead and take a screenshot of this, and then we'll label the rest of the stuff. So if I take a picture of this, put that right here. What we want to do, or what you're going to be asked to do, when x equals -1, oh, that's funny. I got to get rid of those little circles now. When x equals -1, y equals 4. So if I go here, this is like -1, right? Let me do it in red so you guys can see it in red. When x equals -1 here, this is -1, my y value will be 4. So we got -1, 4. You're going to sketch this in your notes. Right here, when x equals 0, I've got 6. When x equals 1, that looks like, what is that? Is that 8? Let me see. Nope, 9, right? That must be 9. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So this is 1, 9. And then if I graph 2, I think that's 13.5. And that would be between 12 and 13. So this is 13 and this is 12. If you don't get it right, just make your dot bigger. It makes it look better. All right? So that's all you're going to be asked to do in your homework, is graph those 4 points. But I kind of taught some other stuff along with it, okay? Shall we move on to the next one?